All right, so we're going through this. This is for those online. I just threw this worksheet online, but I'm actually going to do a couple. So you're supposed to be watching this video if you're at home. So we started this off by x-axis radius, y-axis radius, center. We should at least be able to do that. Student that I chose already told me that this goes up and down because y squared, good axis. Y squared is good axis. Okay, let's move on to somebody else. 20, 5, 10, 15, 20. David, right? Because we go 5, 10, 15, 20 in this class. So, David, what are the vertices? They're actually sitting there on the screen there. Okay, so no, what are the vertices? I need the coordinates. Where are they located? All right, and actually, it has to do with the y-axis radius. You know, we were here, and I went up and down. Those are the vertices. So, what are those as coordinates? Kind of get my screen. 2, 4, and actually, you don't really have to graph it. We can go over here, and I know you're going to get the next one right. I'm at 2, 0, and the vertices are move up 4 and move down 4. So they affect the y coordinate. So what's the other one? That's how you do it, and it's very simple. David, that was a little too easy. How do I find the foci? What's the magic formula? For speed purposes, I'm going to start you off. Oh, that's for an ellipse. So what's it for a hyperbola? Did you say minus?
Yeah.
It's not minus. It's what? Plus for a hyperbola. All right. So, all right. I think this is pretty easy. A squared is 16. B squared is 20 or 9. Whoops. I already had the next number in my head. What's C squared equal to, David? 25. And then what's the C equal to? All right. Now, what are the foci? Where are they located? Well, which way do we go for the foci? Right, left, or up, down now in this particular question? Up, down. And we actually go up 5 from the center and down 5. So it's really the same difficulty level. What are the foci? 2, 5. And there you go. Piece of cake. And we'll move on to a new student, unless the calculator loves you. Student number 9. Nice, Matt, in the 9 position. Now we're going to get to the hard stuff. Let's do eccentricity first. What was eccentricity equal to in a ellipse? What letter over what letter, Matt? It is correctly C over A. Now you can get this real fast. What is C over A?
25 over 15.
It's actually C over A, not C squared over A squared. 5 over 4. So he accidentally said 25 over 16. No, that's the squared versions of that. Now, just to mention this, I like the meaning of an eccentricity for ellipses. Remember the 2 ellipses that I used to have over there? One was really circular, one was really ovular. All right? That's when E is closer to 1. Okay? If you, again, need to sit up here if you can't see back there, I'd like you to do that. No, yes? Okay, all right. So I just want to make sure we're able to do that. All right, and then asymptotes, Matt. First of all, what do the asymptotes both cross? What do they both cross? What point do they share in common? The center. So y minus y1, y minus 0. I don't think you have to write that. Equals m, I'm going to get to that in a minute, times x minus 2. And then, what is this slope? Okay, so there's a couple ways. If I have the picture, you rise over run. Or you look at this and do your radii values. So what is the slope? 4 over 3. And actually, one's negative, so we're going to do a plus minus 4 over 3. And then I'm actually going to do this for you. And don't be a cheater. I had someone in my math tutor just email me, where's the key? I want the key. And honestly, it's someone that I know for a fact doesn't even start their homework yet before they open up the key and then they start writing. And I'm trying to get them to stop. All right? So don't look at this key while you're doing it. Look at it after for checking your answers. But then I just want you to notice that. Look at what they did with the asymptotes. What they did is separate them and then solve each one for y. So I do want you to be aware of that they do that, and it won't necessarily match your answer. You do not have to do this. I just want you to write the one asymptote in that one form there. Plus minus because we do have two different ones. All right, and then that's good. I'm not doing any of these others in this section. You have to do the three on your own. By the way, and make sure I got everything. Yes. By the way, what is underneath x minus 4 squared? Over 1. Don't get goofy about that. What is the x-axis radius? So obviously that's the same thing with this. And then you got the same thing. That one's just fine there too. It looks like I was obsessed with questions where one of the center values is always 0. All right, so sorry that happened. Should have randomized that a little bit. Now we're to this section. Here it is. Completing the square. Those that did not do well in that quiz, and I don't know, I might just type them in today. I don't want you to leave you hanging, those that took it. I always like the ceremony to happen, and then surprise you. But I'll just throw those in, and then we'll do the ceremony later, hopefully today. But the biggest problem was completing the square. I will tell you that this is the hardest, what we got to do with a hyperbola. And if you can handle this, when we revert backwards for review, completing the square should actually fall into place. I hope. That's the hope of any teacher, that we improve on our previous stuff. 7, Ashley, nice. So this is what we should be able to do in 3 steps. So the first thing is, let's mark these up and put them together in our head. What do I have to take out? A 4. And then what does 56 become? Ooh, 4 times 9 is not 56. That's 36. So I know it's a little bit tougher. You want me to just give it to you? Because you probably use a calculator. Be 14, especially when you're put on the spot here. Okay, and then what do I have to take out of y? You definitely have to take this out. Say that one more time. A negative 1. This is a must. What does 18y become? There you go. It's got to be negative 18y so that we factor this correctly. And then you got to get this over here through valid math. So subtract 15. These are not things I should have to show you. Whatever I do to one side, I do to the other. We should be able to move it and understand I moved it through valid math steps. And then I'm going to ask you to fill in the blanks. What's the first blank? 49. Nice. So you know what you're doing. Half of 14 is 7. 7 squared. Next. 81. Half of negative 18 is negative 9 squared. Nice. Careful. What is the next blank, or at least tell me what I'd have to do? 49 times 4. 4 times 50 is 200. Subtract a 4 because it's only 49 fours. 196. And then what's the last blank? You should be able to get that one. It's actually negative 81 that you added to the left side. So you have to balance that off there. Nice. Well done. And again, those that don't know how to complete the square, you're behind severely. You take half the middle term and square it. So this is a very perfect factorable situation. And those that can't factor do not understand completing a square. It's all a snowball effect. It really is. That's why I was complaining all throughout the last months about factoring, because I know how much it hurts when you're not able to. Student 26, student 25 just happened. All right, so you got to go. So factoring this, what does this set of parentheses become? First one right here. So it's x plus 7 squared. X plus 7. One more time. Everybody good foiler? Say it. This is the whole point why I did this. Because that factors to be that. X times x is x squared. Do you remember me doing this in August? All right, good foilers, good factors. 7x and 7x is 14x. 7 times 7 is 49. So x plus 7 times x plus 7 is the correct factorization. By the way, that's x plus 7 squared. Now it looks like I need it to look like to identify the center. What's the next one? And then this is y minus 9 squared. And then through doing this 3 times over to the right, that's a hundo. 100 on the dot. 2 steps. One step is filling in the blanks, through the completing the square process. Second step is factoring, which should be pretty easy at this point. Third step is to divide to get this equal to 1. And then simplify. 4 over that is over 25. All right, flowing along, and I really hope this is helpful. And then change this plus -1 to the minus, so you really see the minus factor. So you see that this is a right, left, or good axis, x-axis, bad axis, y-axis. And then y minus 9 squared, still over 100. And then if you had to graph this, -7, 9, center, x-axis radius 5, right and left, y-axis radius 10, up and down. I did write the 1. My pen betrayed me and stabbed me in the back again. Love this thing. All right, anyway. Oh, I do like to see the screen going like this. Let's get a next student. And this has been rolling along perfectly today. This always gives me positive feelings of where we're at. Make it happen on a quiz and a test. So we have a class average of like 80 or 85. That'd be awesome. And 10 to 12 people getting major or minor awards, whatever. That's the hope. I randomly picked this one. I don't know if you know this worksheet generator. I love it. I just hit spacebar and it regenerates the questions. I forgot to do that. These are all kind of too similar. We got 4x squared and y again. We got 4 and 1. But whatever. And I got 2. That's Angel. Angel, what do I have to take out of the x's? It is definitely a -4, and I'm going to write this way over here because of space. What's the 12 become? Oh, no, and I think you know what the future is, and here comes jerk fraction Mr. Stamulus. He's getting tired of seniors thinking dealing with fractions is like doing a calculus class. It's grade school, all right? And I'm going to start getting all blah, blah, blah about that right now. Is there anything, Angel, you have to take out of the y's? No. So that just stays. This is what I mean about you can do this in 3 steps. You can look at the question and start grouping the things the way you want them and then start thinking about what do I have to do. And then the 73, that's got to go over here. So equals 73 and then plus blankety blank. Don't forget about that. And again, with space, I'm just going to go ahead and do it that way. And then I have been making people do this. So Angel, do you know the first blank? You'll be the first one all day that gets it all by yourself without my help. If you get it. I like this time to let them think. Do not do decimals. Leave it as fractions. Do you need help, Angel? All right. All day long, I'm going to complain to computer. These seniors and their fractions. What's half of -3, Angel, or -3 over 1? Multiply across, and what do you get? And I don't know why students make this tough. I really don't. Because then all you have to do is square it. What's -3 half squared? What's -3 squared? What's 2 squared? 4. So this is 9 over 4. Don't get it. This is baffling to me why we are still having these problems. I've been a fraction jerk all year long because I know how many times fractions come up. And sometimes the calculator has no help for you because it's fractions with variables, or next semester fractions with trig. And we need to know how to add fractions or multiply. What's the next blank, though? That one's easy. Uh-oh, you know how to complete the square, right? What's the next blank? 36. You scared me there for a second. Oh, and then you're nervous about this one because here come these fractions again. Do you know what you actually added to the left side? What did you actually add when you take -4 times 9/4? Which is, you did this the hard way. What's -36 over 4? How many times does 4 go into 36? I didn't hear you, Angel. I think someone else said it. 9. And you did this the hard way because everybody, what happens with the 4s when you take 4 times 9 over 4? What happens with the 4s? They cancel. Why is it when I call on people we don't know this? All right, I've done this too many times to not know that. So we are going to call you out on that. Angel, what's the other blank? Is it just flat out 36? Yeah, it is because that one doesn't have a multiplier out in front. So be aware of those multipliers. Deal with these fractions. Please help poor Mr. Samuelson is going insane with seniors not knowing fractions thing. 4, Reese. Now it's the factoring phase. I'm going to tell you right now the numbers on the page that I need in these parentheses. What is that number? So it is x minus 3 halves. So now I think we're kind of being robotic, and I guess we'll survive on that as long as you write it. But it is this number, but it is true. This times itself does equal that. So that's why this is the factorization. X times x is x squared. X times negative 3 halves twice is negative 6 halves x. That's negative 6 halves x. And negative 3 halves times negative 3 halves is positive 9/4. So that is MA factoring. Next one, Reese. What's that factorization? Y what? Oh, look at that. And what is it? Y plus 6. No reason to make that a minus. And guess what? We got a hundo again. So those numbers being similar ended up being 100 again on the right side. And then, Reese, which way does this go? I want to ask you that so we write this in a really nice way at the end. Which way does this go? Right, left, or up, down? Yeah, I don't know what to do with my hands. It is up, down, because the minus is actually over here. So what we want to do is flip. We want to write this the right way. So, of course, I'm going to divide by 100, and I hope you can handle that I'm just going to do this. But I really do want to write this first. And then minus this, and then 4 over 100 is 25 on the bottom. Oop, got a little pen, little bloop there. And you really do want to see that. So like Reese said, this goes up, down. So we really want to write it in that way. We want to write the minus second, the minus instead of plus a negative on the front. We got to know that. Plus a negative is the same as minus. So on and so forth. So I've done 2 completing the squares, and we successfully got through it all. Everyone answering the questions. Just some fraction hiccups. Everyone has hiccups with fractions. I think every single person I've asked a fraction question, it's been deer in headlights all year long. Yeah, should have started the year with 2 weeks of just adding, subtracting, multiplying, and dividing fractions without a calculator. I mean, it really is true. Okay, now we're into this section. This is really why this is really the notes at this point. We completing the square needed a little help. Wanted to review graphing, just to make sure you know the general idea. Now you haven't had these yet. Some of these get pretty challenging. This one is not, and I refuse to do it. This one is the easiest one on the page. Actually, number 9 and number 14 are the easiest questions on the page, and you should get those answers instantaneously. But I'm going to go to this one because I want this starts the ball rolling, how you get these answered. By the way, everyone, let's all say this in 3 seconds. You're a silly fool, silly fool if you don't do what? 3, 2, 1, go. Graph it. This is parabolas, ellipses, and now hyperbolas. Certainly you want to make a little picture just so you can pictorialize what's going on here. Student number 19, where are we at on that one? She missed. Is it going to be 18 now? That'd be funny. 27. All right, Kaylee again. Kaylee, as we graph this, how do I do 0, 6, and 0, negative 6? Tell me which way I go. Up, down. Didn't want to assume anything. And that's why I like this stuff too. Boy, these conic sections, we got a whole bunch of things reviewed. Dealing with a coordinate plane and moving correctly. Just a whole bunch of algebra skills come out on this. By the way, what's the center, Kaylee? 0, 0. So guess what you have here? And by the way, those are the vertices. So is this an x squared minus y squared, or is it a y squared minus x squared? Which one is it? By the way, knowing these are the vertices, that means these are the vertexes. I like saying that in plural form incorrectly, so we understand what the word vertices means. It means that's what the picture is. So what is that? X squared minus y squared or y squared minus x squared? So this is what we know. And this is worth a point. You've already told me that the center is 0, 0, and you've told me that it's a y squared minus an x squared just by the start of this. So you got 1 point by putting the y squared in the right position. and the x squared in the right position. Right, Nathan? Just a random name call. You all right? That was two Nathans. Good. I got two people at once. Good job, Mr. Samuelis. Thank you, Danny. All right. And then you also know one more thing before I even look at the other stuff. What is this distance from here to here? It's actually an easy question. 6, and that is the what radius?
The y radius.
Y-axis radius. So what do I put under here? 36 is the correct answer. You now have 2 points out of 3. And if you did all the rest of the test right, and we're at least able to do that from this, you're pretty good at this point, right? You know, so minimum, we got to be able to get some of this stuff. Some people just leave questions blank and don't do anything. And I really question that. I really do. All right. And then the last thing, what is the foci? You know what? I'm going to move on. You've done enough. You've gotten 2 out of 3 points so far. 18. Nice. Now we got Lindsay. All right. What's the foci? What letter is that? Are you okay? You look like you want to kill me right now. It was just a calculator that picked you. It's not me. That's why I like the calculator. All right. Anyway, what's the foci? What letter is that? A, B, or C? C. Okay, so that's my C value, and you already have your A squared value. So the only thing you need to tell me is what's that glorious equation that ties C, A, and B together? A squared plus B squared. Don't forget that. All right, and then you already told me that you have 3 root 5 as your A value. And people get over squaring. They get squaring crazy. What do I put next? Do I put 6, 36, or 36 squared? And the answer is it's 36. 36 is A squared. So just leave it as 36. All right? Now, what you got to do, I saw you type on your calculator, man. Darn it. All right, how do you square 3 root 5? First of all, don't look at that answer. What's 3 squared? 9. What's root 5 squared? 3. What's root 5 squared? 5. What's 9 times 5? Is that what the calculator spit out at you when you typed that on there, or no?
No, I didn't.
Okay, gotcha. You knew you were going to be asked. You're like, oh, let me hurry up and type this before he asks me. All right, and then what's B squared equal? When you subtract, what's 45? 45 minus 36. I gave you a hint. It's a perfect square. Oh, no, it's not 1. 45 minus 36. 9. Okay, so what goes underneath here? Here's the question. Is it 3? Is it 9? Or is it 81? I get all these different answers. It's just 9. Okay, and I'm not doing that to be mean. I'm doing that to try to tell everyone else, stop doing the craziness. Yes, the x-axis radius is 3. 3 squared belongs there. Some people put 81. You know, they keep squaring and, you know, it's just going crazy and all that other stuff. All right? So that's and again, your homework yesterday, you should have used that formula quite a few times. No doubt about it, because they asked you to find the foci. So that should have been written down, and you should have that in your back pocket right now, knowing that as you walk in. That's your job, and that's why I should be able to do what I'm doing here. Love this question. All right, I am going to do 11. And so is student Matt, number 9. Okay, Matt, you're a silly fool if you don't do what? So I'm going to put this all the way over here because it's 10. And don't go crazy with it, Matt. Don't go 1, 2, 3, 4, 5, 6. Go 10, 8, and 10, negative 8. And understand that that's what our sketch is right now. Boom and boom. Itchy, itchy. All right. Okay, where's my center at, Matt? 10, 0. Matt, what is this? Is this an x squared minus y squared or y squared minus x squared? You are correct. So, Matt, you have already accomplished. You're going to accomplish again 2 out of 3 points because you at least understand that. And then you have 3 of the 4 missing parts here. What did you say the center was, by the way? I forgot if I asked you that. 10, 0. So now that the center is 10, 0, and by the way, the term vertices means I have this again. You don't have to do this. But, okay, vertices, that means that's what I have. That's why it's a y squared. right? And then what do I put in the parentheses? Y what? So what do I put in there? It would be y, or y minus 0. But I would prefer just y squared there. But if you want to put y minus 0 squared, I'm fine with it. I know that's not simplified, but it really tells somebody what that is. And then how about x? And then not knowing its opposite would be a problem at this point. You're severely and totally behind. Every single stinking conic section, it's x minus whatever the coordinate is. If you're not putting that at this point, I'm getting that red pen and putting a hole through your paper. All right. And then what's this, Matt? What's that number right there? 64. Correct. It's 64. So this has been working well all day long. This is proof that I think we're really starting to get this together. Hey, and then when we go back to ellipses, I mean, the same thing happens, except you don't have a hyperbole. You just have a plus sign, and you should be able to get those. It all like kind of comes together here. Parabola is way different thing, and you got to serial bowl table that. Okay, and now enter. This is the tough part. 3. Aldona. Dun, dun, dun. Aldona, we got a problem. Now they gave us this information. Bummer. But I'm only going to focus on this. Remember what I showed you on the key? They don't show the asymptotes the way I like you to show them. But really, this is all you need is the slope. And then tell me, Aldona, from grade school, what did your teacher say slope was? What r over what r? And then what did your evil senior teacher, Mr. Samuelis, tell you on slopes of asymptotes? The rise is actually which axis? The y-axis radius or the x-axis radius? Y-axis radius. So the rise is actually the y-axis radius. Evil math teacher. Over x-axis radius. But we got a problem, Aldona. 2 is 2 over 1. Right? Don't you agree with that? And by the way, what did Matt find as the y-axis radius over here? What is it actually? 8. So this is what we're going to do, Aldona. The y-axis radius is actually 8. So what does that mean the x-axis radius actually is? Oh, 8 over 16 is 1/2. This is 2 over 1. So it's actually what? 8 over what equals 2? You're getting a brain lock. You're getting the deer in headlights thing. You're overthinking it. 8 divided by what is 2? 4. So you overdid it. And that's what's special about this one. This actually has the biggest wrinkle of it all, but it's very tiny. You just have to understand that the slope is always in reduced form. The actual rectangle value is 8 for the slope rise. So the run must be 4. Aldona, what goes underneath x squared now? You are correct. It's 16. It's that 4 squared. There are a couple other questions in here that we have a fractional reduced version here, and you got to account for it. Okay? So the slope of the asymptote is really all I have to extract out of that to get my other piece of information. And that's all you need to do about that. Okay, yeehaw. Gonna be a cowboy, cowboy baby. Anyone know that song? Alrighty then. Who's my next friend? This is how I pick my friends. Oh, you're my friend. I got you on the calculator. Kaylee. Couldn't have friends any other way. Kaylee, how many times have you gone? Third? That's the rule. After this, you don't have to go. Okay, so silly fool if you don't graph. Whoops, grab a pen. Silly fool if you don't grab a pen to graph. 1, 1, 2, 3, 4, 5, 6, 7. Okay, now focus. Endpoints of the conjugate. Is she listening? Endpoints of the conjugate, bad axis. What is this? Is this an x squared minus y squared? Or is it a y squared minus x squared? Oh. Why? Because this is the bad axis. This is not where the parabolas are, or the one hyperbola. I like calling them two graphs parabolas. They're actually this way because that's the bad axis. So this is an x squared minus a y squared. So be careful when they give you the conjugate axis. That's the bad axis. That means the good axis goes the other way. And then that's what we got. And then always equals 1. Ooh, might have to take a half point off if you don't put equals 1. It's got to be an equation. All right. Reese, you okay over there? You look bored. All right? All right, good. Spot check. What is the center? I gave you a chance to think about that. It's still able to be achieved with this being the conjugate axis. So what's the center? Oh, last hour said 1, 5. They counted wrong. You both counted wrong. So what do you think? 1, 4. Okay, so 1, 4, which is, I don't want to tell you. Okay, so tell me what goes in here now. Tell me what goes inside here.
X minus 1.
And then what? Y minus 4. Good. So guess what? You got 1 point. I mean, a half point for which one is it, x squared or y squared? And then another half point for center. But then you have something else. What's this distance from here to here?
2.
Oh,
3.
3. From 1 to 7 is 6 away. So 6 away, this is now 3 away. Where does that go? Like, who do I put under what now?
You would 9
Good.
1
Nice. And now you got 2 out of 3 points. All right, and you need to understand that, how critical this is. Just these 2 little points here, I can find the center, and I know a radius value. Three out of 4 positions filled in there. So simple. Not so simple. Enter 6. I feel like that's a new one. Sarah. Look at this, Sarah. And then this is if you did your homework yesterday, which I think you do, right? This is how you were supposed to do the foci yesterday. If you got a foci value that was a radical, you were supposed to just tack it on the correct coordinate, right? And this is going right, left, and lo and behold, look, 1 comma 4, 1 comma 4. So guess what this represents? It represents a letter, A, B, or C. And the answer should be that this is the foci, so what letter is it? Oh no, A is already, actually we don't know A, so what's left? C. The foci are the C values, okay? So that is what that is, and that's why I love this worksheet, because they really do this like in reverse analysis. If you did your homework correctly, that's how you wrote the foci yesterday. So therefore, that sticks out like a sore thumb that that's my C value. The tack on to the center, right and left. And certainly right and left when you affect the x coordinates. So this is definitely an x squared. Okay, so anyway, magic formula, c squared equals a squared plus b squared. Shouldn't have to ask that again of Sarah. I will ask her this, though, without a calculator. What's 3 root 10 squared? Tell me your guess as we write this down. What's 3 squared? What's root 10 squared? 10. What's 9 times 10? 90. That's why we don't need those stinking calculators. 90 equals a squared plus 9. What's a squared equal to when you subtract 9? No, when I subtract 9, what's 90 minus 9? 81, a nice perfect square. All right, so we got that information. There's your last point. All right, and even though that's the hardest, I'll still just grant 1 point on that. So anyway, like 2 out of 3 points, and if the rest of the test is good, that's where you get at least some points for something. All right, I think this one, I'm not going to do it, but I think you have a reduction thing again. What's eccentricity one more time, class? What letter over what letter? 3, 2, 1, go. C over A. But is that truly A, or is that reduced? It is. I'm giving you a hint. I'm not going to do that one, though. Easiest question on the whole page. You get that wrong, I'm going to cry. All right. Then I got one of these last four, and I really love this worksheet generator because they've got some unique questions I've never thought about before. Not that they're hard, they just have a different perspective in how they look at things. So I'm going to do 15 and then talk about this reduction thing. And do I have to worry about that? 11, which is never been in this. No, that's right. You moved. Didn't 10 come up before? Nice. Now it's you, Grant. All right, Grant, you're a silly fool of what? You don't graph. And then -7 to. Okay. Actually, Grant, this gave you more than all the other questions. First of all, is this an x squared minus y squared, or is it a y squared minus x squared? Okay, you're killing me, Smalls, because that's called a what? Say that word right now. We're going to talk through it. Vertex, which means is this hyperbola here, or is it not? If it truly is a vertex. So therefore, this is going right left. Which axis goes right left? The x-axis or the y? You need to know that then. You have to have picked that up at this point. I'm going to call you out on that. So what is this now? An x squared minus y squared or y squared minus x squared? You got it. All right, so let's go, man. Let's do it. Gotta call you out on that. That at this point is what we've established in 5, 6, 7 different examples. The word vertex means this is a vertex for one of these. So therefore it goes along the x-axis. Next thing is you fill in these. Because actually that's what I mean about it gave you this already. So what do I put in here? So it's -2 because of 2 being this x coordinate. And then what about the other one? There you go. So you got 1 point. Okay, you got 1 point right now. You actually have a second point. Oh no, that's 9. So what goes underneath here? Not 9. Okay, look at everybody else here. I'm going to go back to this graph all the way up at the beginning. 16, but what did we actually move? 4. So 4 squared in the equation. 4 squared. So what actually goes here? So the move is 9. Where am I? The move is 9. So what goes here? 81. All right. So we got to get this down. I'm going to stay on you now here. Okay. And then look at that. We're 3 out of 4 points. All right. Or, well, 2 out of 3. What? Okay. And then this was the last one I was going to do. And then what letter over what letter's eccentricity as we ignore her? And guess what? What is your A? A is what? You already found A to be what? So this is reduced. So I can say C is 106, square root of it. So now when I use my equation, as I run out of time, and my pen is a jerk, because I can't write with it, 81 plus B squared. Oh my gosh, the pen won't write. Square root of 106 squared is just 106. What's 106 minus 81, everybody? 20, 25. This worksheet likes making the numbers work out perfectly. That is where I wanted to end. The rest of this is all your homework. Hey, by the way, look at how we end here, completing the square. In 3 seconds, as you put your page away, what is that actually a graph of? It's not a hyperbola. 3, 2, 1, go. Different numbers in front of the positive squares means it's a what? Ellipse. It could never be a parabola because a parabola has what? Only what? So therefore, what is number 20? 3, 2, 1, go. Parabola. So I wanted to throw 2 more complete the squares at the end of this to show how those work a little different, and you can practice that. That's really the biggest problem on our test. Oh, I forgot this class lines up, and they're all mad at me because they didn't get the line up early.